So for this experiment, we're gonna need an egg, a jar with a lid, and vinegar. And all you're gonna do is put the egg at the bottom of your jar without breaking it. And then you're gonna put enough vinegar in to cover the egg. So about that much. And then you're gonna cover and let it sit for 2 days or 48 hours. And after 2 days, you will have a squishy egg. You'll have to rinse off the eggshell. I've already done that for recording purposes, but it should be squishy and kind of see-through.
Hey guys, so in this experiment we'll be doing a try-at-home experiment called red cabbage indicator. Red cabbage has toxins in it which can serve as an indicator which can tell if a solution is acidic or basic. First you'll need to grab a red cabbage and then you can chop it up or just peel it off like I have and put it in a beaker or a bowl at home with some water. And once you have enough in there, you just turn on the heat for about 10 or 15 minutes and you'll come back and check on it in that time. Once you've boiled out the cabbage, you should be able to extract your red cabbage solution. This solution contains a toxin inside of the cabbage, which can serve as an indicator. When added to different chemicals, you can see a change in color, which will reflect if it's acidic, basic, or even neutral. Its neutral color is a purplish color like this, where it's due to it being in water, which is roughly close to a pH of 7. If you add it to a strong base like NaOH, sodium hydroxide, you'll see a green color, which indicates it's really basic. If you go down in pH, if you get something a little less basic, right here we have baking soda. It's a bluish green color, which can tell you that it's a little less basic, but it's still basic. If you use a strong acid, like HCl, which is the other side of the pH scale, which would be close to 1 in a pH unit, it should turn red. And indeed it does, and it's a dark red color. And we have a couple other acids here, which are household chemicals, not chemicals, but household materials you can find at home, like lemon juice. And this also turns red, which indicates it's really basic or really acidic. And same for vinegar, which indicates they're acidic. So you can test this out on different chemicals at home, and it's pretty cool. You get this remnants of the cabbage and throw that away and use the liquid, and you can indicate pHs on household items.
So this experiment is called the can crushing, and you can try this experiment at home. But you need to be careful when you're holding the can because it's going to be hot. Okay, first to do this experiment, you have to fill like a small amount of water and keep like the can with the water inside the can to heat up. Then you need to get like in a bucket. Here I'm using a beaker filled with cold water. You can add ice.
So the theory behind this experiment is to show how the difference between the outside pressure and the inside pressure can cause the can to crush. So basically what happens now is that when the can is inverted in cold water, the steam of the hot water inside the can condenses, resulting in a lower pressure inside the can. Then because of the difference and the pressure inside the can and the atmospheric pressure outside, an inward force on the walls of the is applied, causing the can to crush.
So now in this experiment, we're going to do the open toothpaste and you can try this experiment in that room. What you need the hydrogen peroxide. You can get it from grocery store or any store, and you need the dish soap. And this experiment, I'm using the potassium iodide. You can use ESMC, but first you have what is called the active yeast and then a small amount of water. Okay, I have this tube. Hydrogen peroxide around like 5 ml, and here I have like around 5 ml of potassium iodide. And first I need to have, you need to have food coloring, just to show like that. So I'm going to have 2 drops. And 2 drops this soap. And now I'm glad the potassium iodide. Be careful when you add the potassium iodide, since it's once the hydrogen iodide is added, the hydrogen peroxide will decompose and it will produce oxygen, so be away from any flame. So as you can see now, the soap is forming because, as I mentioned earlier, the hydrogen peroxide is decomposing and producing the oxygen, and that's what's stopping the bubbles. And you will have the same effect when you use the yeast instead.
Sugar has a lot of energy stored in it, and in this experiment we will show how much energy are in there in sugar. And also sugar is known as a carbohydrate, which is considered as the source of energy in our bodies. To start this experiment first, we have to heat the solid potassium chlorate to allow the oxygen atom in the potassium chlorate to ignite the gummy once it's dropped inside the tube, and then causing it to release all the energy it has along with water and carbon dioxide. This reaction also is known to be an exothermic reaction, which means it releases energy.
Now we'll do some demonstration with the liquid nitrogen. Okay, the liquid nitrogen it boils at 77 Kelvin, which is equivalent to the negative 320 Fahrenheit. It's also the liquid nitrogen is used like sometimes to make ice cream with the liquid nitrogen, and also in science or in the labs, especially like in the biochemistry and biological science, as they use it like store proteins and tissues. So let's do some demonstration with the liquid nitrogen. What do you think if I put the kettle with the liquid nitrogen? Well, let's find out. The kettle starts boiling, and that's because the liquid nitrogen is boiling, but it has a very low boiling point, and that's why it's whistling as it's being boiled. What's going to happen to the balloon if I put in the liquid nitrogen? Well, the balloons shrink, and that's because that we can link it to the ideal gas law, which is the equivalent of P, and that's the pressure times the volume equal to the number of moles of the gas times the gas constant, and as well as the temperature. And when I put the liquid nitrogen or the gas when I put the balloon inside the liquid nitrogen, the temperature difference because the pressure can lower as the temperature is very low. What do you think will happen to the cabbage if I put it in the liquid nitrogen? Well, let's find out. Well, it falls and it stops, like if you hit it with anything, it will stop breaking apart.